Thank you everyone for joining our webinar today on key differences between on-prem and cloud data platforms. We've got some great content to share with you today about data lakes and data warehouses, as well as some of the differences in why we recommend companies start looking at cloud data platforms. A couple housekeeping items before we get started. We are recording today's webinar, so everyone will receive a link following today's live session. Please feel free to share that with your colleagues, watch again, or if you do have any questions too along the way, we will have a Q&A session at the end of the presentation. Also feel free to submit your questions as we go, and we'll try to address those. Last thing before we kick this off, I also want to call everyone's attention. We've got a couple attachments and links that's available to everyone. One of them is a free ebook from O'Reilly around operationalizing the data lake, which I would highly recommend everyone check out. So with that, I want to introduce our speaker today. Parang is a solutions architect here at Qubole and has spent a lot of time working with customers as well as prospects, kind of how to think about their architecture, kind of the value of, and how to get the most value out of their data lakes and their data itself. So with that, Parang, I will hand it over to you.
Thank you, Steve. So I wanted to start this presentation. IDC predicts that the global data sphere will grow from 32 zettabytes in 2018 to 175 zettabytes by 2025, right? So just to understand and grasp this volume of data that is going to grow in 7 years, we have 5 times more data than that will be produced. What that means is the digitization of our economy is growing and growing fast at very rapid pace, right? So where IDC believes that where all this data is being produced is going to be stored in various different ways, but they segment this storage into 3 different parts. The first part, they believe the data will be stored in the core location, which is either it is a traditional or cloud data centers. The second place where the data is going to get stored is in some of the endpoint location, they call it, which is either the personal computers, smartphone, IoT device, and so forth. So data gathered from these endpoints will be collected at edge locations, but then will be stored in small to medium enterprise where the infrastructure, such as small company data centers or medium-sized data centers, will be hosted. So in all, there will be a lot of data being generated, and that challenge remains for the companies that if they have a digital strategy, data first needs, right? How to collect this data, where to store this data, and what is the right platform to use to process this data, right? So these are some of the considerations that we need to have in back of our mind for digital first strategy. That being said, I wanted to set up an agenda for today where we will understand what the data lake is and what makes cloud a better data, storage for the data lake, right? And we will see the first phase, we will see this difference between on-premise and cloud data lake. In the second phase, we will go and understand the difference between a cloud data lake and cloud data warehouses. And towards the end, we'll see what kind of platform or big data platform specifically that is required to process this large volume of data. So let's take the first phase to understand what a data lake is. So in looking at this slide, first of all, as we just a lot of different places today, and that data can be in, needs to be stored in a raw format, right? And what that means is usually these are objects, blobs, or files which needs to be stored. And most of this data being either, generated through various means, but at the end, the raw copies of this data needs to be stored. So it will be a single storage location where all the enterprise being stored is generally referred to as a data lake. Now, this data lake generally include, structured data that is either generated from some of the relational databases or data warehouses, or it could be unstructured or semi-structured data, such as CSV file, log files, or XML files, JSON files, and so forth, or unstructured data such as emails and PDFs and documents like that. Also, a lot of companies now generating digital content. What that means, images, audio files, video files are also, which is binary data that also needs to be stored. And this all being, data collected and stored in a single location that is generally referred to as a data lake. Now, where, after the collection of data, obviously this data is used for various purposes, such as reporting, visualization, analytics, and advanced analytics, machine learning, and AI. And the reason that this data is being used for all these reasons, because they have a single source of truth. And this data is collected and stored in a raw and relational format, right? One thing to watch out for when we are, companies when start using the data lake is generally, they have a tendency to create something they call a data swamp. And what that means is, while this vast amount of data is being collected, they make it inaccessible to, some of the users. And if that happens, they're generally referred to as, data swamp. And what that means is companies are not able to leverage the value from the data collected. Moving on to, another factoid that, this vast amount of data being collected, IDC predicts that 49 or close to 50% of the data will be stored in a public cloud environments. And let's try to understand why is that. In a second. So what that means is, the reason for IDC predicting the vast amount of data being stored on data lake is for some of the let's understand the difference between on-prem and cloud data lake, right? So generally, on-prem data lake is typically being, generated using some of the older technologies or other technologies came way before this time, right, is on-prem Hadoop infrastructure, right? And what that means is when, companies started creating on-prem data lake using, traditional Hadoop on-prem solutions, the primary difference was the storage and compute were tied together, right? And versus in cloud, you get clear separation from storage and compute. And we will dive this into much more detail in, later on. The other few differences, or the primary one, are, availability and durability, right? So while, on-prem data lake traditionally used, with on-prem Hadoop infrastructure, their availability and durability is tied to, the on-prem Hadoop hardware, right? And versus on cloud data lake today, we have, cloud providers provide very high availability and very high durability, right? So we have 11 nines of, durability and availability is pretty close to 100%. So pretty much most of the companies, don't have to day-to-day worry about losing the data or data not being available to their end users. Other advantage of, cloud data lake, we can see here, right, that scalability and, integration is very easy. So because cloud offers elasticity, the scalability is never a challenge. Where companies, collecting more and more data, obviously they need to scale up their storage. And if they go with on-prem solutions, obviously they need to have heavy investment in infrastructure and storage infrastructure as well. Versus on a cloud data lake, due to elasticity, the storage is pretty much unlimited. The most differentiated item here is transactions. So typically, Hadoop type infrastructure, on-prem infrastructure had transactional capabilities, which was not possible earlier. But now with the release of Hive 3x, we have online availability of transaction on Cloud Data Lake as well. Moving on from here, the differences, I want to make sure that we really hammer on some of the consideration that each one of you should have on using data lake on the cloud. So as we briefly looked at, the cost effectiveness and the elasticity, first of all, the cost effectiveness on the cloud is also very promising. Today, storing data on a cloud is one of the cheapest way to store data compared to any other way or medium collecting hardware on-prem, right? On demand, we have a petabyte scale of storage available in the cloud. So and obviously with the pay-as-you-go or pay-as-you-use model and software as a service model on the cloud for storage, really it makes it so easy to use storage on the cloud. Availability, we already looked at it, but what that means for some of the differentiation compared to on-prem is really because of high availability and durability of our data on the cloud, companies really don't have to worry about day-to-day about the backups and disaster recovery issues once they use data lake on the cloud. The primary differentiation we just briefly touched earlier, right, is what cloud provides or data lake on the cloud provides is separation of storage and compute. And this is a huge differentiator as you mature your journey into the cloud, where you want to make sure that your storage and compute are separated in the sense that when you start collecting and storing more and more data, you really should not have to scale your compute unit just for storing more data. And traditional on-prem, Hadoop kind of environment really, ties storage and compute together, and that's why it is very difficult to economically scale up your storage without, scaling up the compute. When you start collecting data from various data sources and various endpoints, such as digital devices and IoT devices, you want to make sure that your data is stored in various open data formats. These data formats basically are specially geared towards, processing large amount of data or large, big size of files very easily. And some of these formats, such as Avro and ORC and Parquet, are very popular and useful formats where how to store your data files on the cloud. And they are pretty much open source format. What that means is there are various engines or open source engines are available that can optimize use of this large volume of data for processing. Last but not the least, the transactional support. Which was not possible earlier, almost May of 2018 or earlier, is transactional support, which is available on the data lake today. So with Apache Hive engine 3.x, and we have now transactional support available also on data lake, which is a huge differentiator for the cloud data lake today. So that being said, I wanted to move on to our next topic, that what are the difference between, so a lot of people, when they start collecting the data on the cloud, they do also consider cloud data warehouse as a possible storage engine as well. So let's understand what is difference between storage available on the as a cloud data lake solution versus storing the data in the cloud data warehouses. So now, here, obviously, you all can see, the slides, but I wanted to point out that few of the items here, right? So as we saw earlier, the importance where once the company start collecting a lot of different variety of data, the type of data being collected and stored is very much important. So traditionally on cloud data warehouses, you can only store structured data, right? So typically that data comes from some of the other databases or operational data storage and being transaction into some of the cloud data warehouses. Versus when you use Cloud Data Lake, you are collecting various types of data, which includes structured, semi-structured, and unstructured data. And that's why Cloud Data Lake makes it easy to store data from pretty much any source anytime. Generally, when people use cloud data warehouses, then their purpose of storing and using the cloud data warehouses are limited use cases, such as they focus on using that data through some of the SQL or SQL engines or BI tools. Versus when people start storing and using the data on cloud data lakes, they have capability to use data in addition to those BI tools, but other for predictive analysis, machine learning, and AI. And the reason that is that there are so many different open source engines are available that they can take advantage in the cloud versus, so to speak, traditional engine, which is or single engine which is connected to cloud data warehouses. The challenge with using cloud data warehouse is that some of the expertise required are available, right? So traditionally, companies have used data warehouses on-prem, and then for them, it is easy to transition into cloud data warehouses. So primary source of those data usage through data analysts or BI tools are kind of easy transition for them. Versus on Cloud Data Lake, somewhat different skill sets are required, and generally those skills are easy. Not time these skills are you can find data engineers, data scientists, and data analysts. They can really take advantage of data for their predictive analysis and machine learning and AI. So if you have expertise or you have a skill set which are kind of geared towards new paradigm of digitization, you need to have a certain skill set or engineers and data scientists which can take advantage of this vast amount of data. Obviously, cloud data warehouse you can scale as well, but the challenge with the cloud data warehouse is their schema is kind of fixed, right? So unfortunately, what happens is when you want to process different sets of data or data with different schemas, then it requires some engineering effort to be able to update the schema or create a new data warehouses and so forth. Versus in Cloud Data Lake, Data Lake is basically doesn't have any fixed schema, right? As we have seen, any type of data can be stored on Cloud Data Lake. So schema is very flexible. There is no fixed schema in that sense, right? And generally, the cloud, the big data processing engine available today, they usually use schema on read. And when they do that, obviously, the schema on the fly can be changed or accommodated during different kind of processing. So moving on from here, as we have seen the difference of cloud data warehouses and cloud data lake, let's try to understand why Qubole as a platform makes an ideal platform for processing your big data workload. And I wanted to start that with another factoid based on some of the survey that we conducted earlier last year. What we have observed from different, the companies that we have surveyed, that compared to 58% of companies in 2007 that started using, cloud or one of the cloud providers, 73% of the companies we surveyed in 2008 started using cloud solutions. And that being said, the challenge is just using cloud solution or cloud data lake, brings up another type of challenges, where many companies traditionally with they do not start with a big data platform. They see their big data projects fail to meet expectations for 80% of the time. Or in other words, 70% of the big data potential value is unrealized. So while companies are collecting a vast amount of data and different amount of, different type of data, they unable to realize the potential from that data. And let's understand the reasons why that is the case. And when we analyze those, some of the issues that came up, we came up with this understanding that some of the challenges of using the data we define as an activation gap. While what happens is volume and variety of data start increasing, a lot of business users or end users, such as data analysts and scientists, really have a lot of different use cases they would like to either experiment and try using the big volume of data. But at the same time, data security concern, data storage, data organization concern, user expectations and the behaviors, increasing, the skill set that is available to manage those data stores and able to process this data source remain, kind of flat, right? So with the IT budget being flat and the skills sets not being easily available, the activation gap remains very, very high. And that being said, wanted to bring you to another type of challenges that we just referred to, right? That in a different way, where typically if you look at this screen, on the center, we represent something called data team. And that data team generally either is considered operational teams or data operations team. They come under a lot of pressure when, during the exploding data set and changing workload. New data types are suddenly being, available to use, but then they have to collect, organize, and make those data available to, more users who wants to access those data and leverage their data for their business needs. So typically, these data teams end up, try to creating their own data infrastructure, try to create what is typically generally available in ready-made data platform. They try to create themselves, and they really get bogged down with a lot of other, challenges. And that ends up being some of the, potential of data not being utilized or miss SLAs for some of the workloads. And that becomes a challenge for the company that they see of cloud cost increasing, but not being able to derive the values from their cloud infrastructure. So now let's focus on what some of the key benefits of cloud data platform first, before we dive into the data platform that Qubole offers. Now, generally, some of the key benefits that you see here, let's talk about each one of them individually. And the scalability, right? So now we just talked about earlier that what cloud data lake or cloud as offers is a separation of your storage and processing, right? So what that means, you can individually or separately scale up your cloud infrastructure for storage and for processing needs. So when you have a lot of data to process, if you want to scale up your processing engines or processing power, you can easily do that on the cloud, on any of the cloud provider. Elasticity, again, elasticity, which is available for both your storage and compute, is one of the primary consideration where you when you want to process small amount of data in quickly, then obviously you can scale up your processing engine very effectively. Cloud service with various service being offered on the cloud, they are generally referred to as a self-service or in a collaborative nature, right? Where support all the users as long as the data is being provisioned on the data lake and necessary permissions has been given for each user or user group, then what effectively becomes a self-service platform for everyone in the organizations to consume that data. Obviously, the data platform being easily available, there is a faster time to value, and cost efficiency of the cloud, we already know that only pay for what you use, right? So for that model, which works so that companies don't have to invest in any heavy infrastructure and don't have to spend capital today, and they can only pay for what they use. Obviously, cloud makes it very easy to monitor and track your usages, because they essentially charge you based on your usage, and they make it easy for you to monitor and track your usage. So after looking at some of the advantages of what cloud offers or the data platform typically is available in the cloud, let's look at what cloud native data platform that Qubole offers. So if you're looking at this slide, just wanted to have you focus on very bottom of the screen where it talks about data lake and then various cloud. So Qubole platform is a cloud native or cloud agnostic data platform. What that means is the complexity of the cloud that generally administrator and data platform administrator have to deal with are kind of abstracted from them. So Qubole being a cloud native data platform, it can seamlessly operate irrespective of the cloud vendor that you decide to use or you're using today. As long as the data is available in the respective data lake or of each or the cloud vendors, blob storage or file storage as a data lake, all the files are available within the data lake, then Qubole platform is able to leverage that data for processing. Now you can see here that the platform itself supports various personas, right? So these personas, that means is data engineers, data analysts, and data scientists. So each personas obviously have different roles or different needs. What that means is, for data engineers to be able to, run their ETL workload or ELT workload, they generally prefer to use Hive and Hadoop on Hive as a primary source of engine. Versus data analysts, they typically end up using open source Presto as an engine. And data scientists generally prefer to work with Spark engine. So while each personas have different needs, the challenge remains with the platform administrator to how to make sure to install, configure, and optimize the use of these engines. But Qubole data platform actually makes it very easy to create or instantiate any of the engines on their own cluster. And they provide something called, we refer to as a self-service access. So while we do provide a role-based access control for each personas out of the box, the self-service access makes it easy for each type of group of people to leverage the data from data lake. On top of the self-service access, we provide full financial governance. What that typically means is for companies when they mature their journey in the cloud, typically they end up, looking at the cloud cost in different ways. And really, it is sometimes hard for them to understand where the money is being spent while they are started using data platforms. Qubole being a differentiator here, that Qubole provides financial governance in various ways. So obviously, we provide up to the dollar amount how your dollar is being spent on the cloud platform, such as we can provide details that which people or which personas have used the platform, which engines they have used, what are the interface they have used, and we can nail down the cost of using a platform for financial governance reasons. Obviously, we support multiple use cases that are being used by any of this persona today, and most importantly, we consider this platform as an enterprise platform. What that means is generally, when enterprises start using cloud data platform, the security is one of the most important concerns. So cloud data platform such as Qubole, what they provide is data security from various point of view. So when you store your data, you have a way to encrypt your data stored in the cloud. So Qubole is able to process both data being stored in REST as an encryption format. Qubole supports that. At the same time, data being in transit from your data lake to your cluster for processing, we support encryption as well. So on top of that, obviously, the single sign-on for authentication and various authorization mechanism using role-based control is also available part of this platform. So some of the typical security concerns that companies have are kind of being addressed in the platform as well. What that means is using Qubole platform, what companies can do that they can start leveraging the data stored in a data lake using various engines, which are shown here. And these, I wanted to clear one more other things about this platform, is that this platform actually is using some of the open source engines which are highly used by various companies today, which are data first companies that we call it, right? So data first companies really don't want to use any proprietary engines or proprietary file formats for their processing. They want to make sure that data available within the cloud data lake can be ingested and used by a variety of engines at the same time. And I wanted to then lead you to this issue with the Qubole architecture and provide you more detail how Qubole is able to accommodate that. So if you look at this platform, what typically happens is if you see Qubole in the center of this diagram. And Qubole, and on your left, you have your own account, whether it is your account is in AWS, Google, GCP, Azure, or Oracle. Qubole becomes an orchestration engine for your cloud. So what Qubole is able to do is able to create and scale up the compute cluster within your own account. What that allows you to keep your data within your own account. So the data lake that we talked about earlier is storing and having the data available within your own data lake is being only accessed by the clusters within your own account. Qubole is being an orchestration platform, only manages the data in and out from data lake into your own clusters. And then after the processing of your data is being moved back, or the results are being stored back into data lake. What Qubole also allows you to ingest the data from a variety of sources. What that means is if you look at the diagram on your towards the left of it, Qubole is able to integrate and access data from various data sources, such as traditional RDBMS, which could be on-prem, and data warehouses. Also, Qubole is able to ingest data from other databases, such as NoSQL databases, such as MySQL or Elasticsearch. At the same time, new capabilities are coming into Qubole platform to ingest the streaming data as well. So Qubole is, in that sense, able to ingest data from variety of sources and being able to process through various open source engines. These open source engines can be leveraged, obviously, through various interfaces or user interface that Qubole provides. Through Qubole interface, obviously, you can explore the data. What that means is that if your data is stored either in your data lake or your traditional data warehouses, through Qubole, you can explore that data and see what data looks like today. Why that is important is while the various users need to process that data, they want to understand what the schema or data is structured or semi-structured, or how to write actually the query using some of the schema available on those data. So you explore through Explore interface that data, and at the same time we provide other interfaces such as Analyze and Notebooks, through which you can create your workload and submit your workload through various engines that we provide. In addition, Qubole provides other ways of accessing the platform as well. So Qubole obviously provides various SDKs, such as Python and Java SDKs, through which you can submit your workload as well. Qubole provides REST API as well. So you have, if you're using any language other than Python or Java, REST APIs can be used. Qubole provides a specialized JDBC and ODBC drivers. So if you're using any BI tools such as Tableau or Looker, that can be used to access data on the cloud as well. Or specifically what I mean is the data on data lake as well. So really, once you store your data on data lake, it can be processed through Qubole, through various engines, and also through various BI tools. As I mentioned briefly earlier, the security control and governance also is part of the platform. So, for enterprise usage and integration perspective, this platform makes it so easy to get on board and leverage the data stored in the data lake. Additionally, Qubole also provides dashboards. So for when you create your workload using notebooks, those notebooks can be actually make it can be also be the results of those notebooks can be displayed on a dashboard as well. So if you have users which are C-level suite users, which really doesn't day-to-day interact with the platform, but they need to see the results of the BI or the prediction that you create, that they can use leverage the dashboard capabilities as well. So just wanted to wrap up this presentation as we need to have some time for Q&A towards the end. Why some of our customers use Qubole today? So Qubole allows you to integrate and leverage the data in the data lake much faster than any other platform that you can create or is available in the market today. We allow faster innovation through self-service access to the data, and you can run various use cases on your data through various engines that we provide. So what that means is that we have a shared infrastructure, a single platform, which shares the infrastructure and provides various engines with your service. All these engines are actually much more powerful than the open source engine in the sense that they are optimized for the cloud. As we kind of hide the complexity of various cloud for you, we make this engine cloud agnostic as well. In addition to making this cloud agnostic, these engines are made to perform much more faster and to increase your SLAs for your workload. So, we remove some of the challenges for data administrator as well. So many of our customers that I work with today is able to leverage the self-service platform for so many users without having to have platform administrator in the same way that they had to do it before. And we see almost 10 times more users being supported on a platform by a single administrator compared to before. Last but not the least, right, we actually lower your cost of running your workload on the cloud. What typically available from various cloud providers is something we refer to generally in AWS as a spot node, or a way to kind of bid for lower cost instances. And we make it easier to buy those spot instances. The primary capability of lowering the cost is about auto-scaling. When we, what typically we refer to our platform as a workload auto-scaling. Especially the cloud platform being able to use by multiple of users, we make sure that we understand the workload being submitted on the cloud, our platform, at any moment of time. While users are able to start their cluster with a minimum number of nodes, as we see the more workload coming on the platform, we actually auto-scale those workload and increase the number of nodes on the cluster as the more users come on board or more workload being submitted on the cluster. And typically it ends up being optimized the usage of the cluster and giving you significant cost savings. And we have seen cost savings up to 50% in many cases. So these are some of the comparison and for having having a cloud data lake, and on top of using the cloud data platform such as Qubole to be able to go to the market faster and to reduce your cloud cost through various auto scaling mechanism and spot buying mechanism that we provide. Yeah. So I just wanted to leave you with some of the takeaways for the day before we run into the Q&A session, that some of the customers I work with, they leverage cloud or cloud native big data platforms such as Qubole to leverage some of the open source capability and engines that we offer. More common is the single UI that we offer on top of the platform or software as a service. That is being very valuable where some of the you don't have to put pieces of the puzzle together, right? So platform as a service and on top of software as a service, which is very valuable for moving your workload to the cloud and using the data stored in the data lake in much faster and cheaper way. The self-service access for data users is paramount, as we wanted to make sure that the data is available to all the users and the data can be leveraged for potential business use cases. So we make it self-serve access to the platform as well. So, these are some of the takeaways that I would like you to have. And I wanted to just conclude the presentation and leading up to Q&A session as well. Steve, do we have any questions from the audience?
We do. We do have one so far, but I did want to pause for a second. First of all, thanks for Ring for taking us through that content. If you do have any questions, please submit them, and we've got a good 15 minutes if we want to continue. Otherwise, we'll get to the one that we have. I did also want to call out again, if you're interested in getting kind of hands-on with Qubole on the platform and some of the capabilities that Param touched on, we do have a free trial. The link is listed there. as well as in the attachments and links section. So the question that did come in, Pravaan, was how does Qubole help companies move data from on-prem to the cloud? Do you want to maybe just touch quickly on the services component?
Absolutely. Thanks, Steve. So Qubole has a professional services unit, and we work with many companies actually to move their on-premises data to the cloud. Not only that, we help them with architectural issues, or giving them solutions that generally they're not familiar with in how to use leverage various different engines that we offer as well.
Perfect. Thank you. All right. I will pause for 15 seconds, see if any other questions come in. Okay. Looks like those are the questions that we've got. Thank you, everyone, for joining us today. We appreciate you taking time out of your day. And thank you again, Pravaan, for taking us through all that great content. With that concludes our webinar. Thank you, everyone. We'll talk soon.